So now we're going to look at how we sketch a graph of the derivative. So f prime of x is our derivative. Here's a graph of just f of x. By using our knowledge of what derivative is, we can sketch a graph of this. So I'm just going to go ahead and sketch my graph right on top of this graph, so that way maybe it can make more sense than graphing it separately. So remember that the derivative is the slope, right? So derivative and slope go hand in hand here. So the graph that we have here, we can see there's different pieces of the slope, right? So as we draw this graph, the slope is positive. When it gets to this little maximum over here, it has a slope of 0 at the top. Then the slope decreases. Then it has a slope of 0 at the bottom. Then the slope increases. So what we would do here is figure out where the slope is 0. Okay, wherever the slope is 0, the derivative graph will be crossing the x-axis at that point. So I'm going to put like a little dotted line here just to say, okay, here about is where my slope is going to be 0. So if I were to carry this down somewhere, right, it would be about here. Okay, same thing here. If I carry it up a little bit, it's going to be about here. So those are where the points where my derivative is going to cross the x-axis. Now, from the bottom of my graph here, the bottom left, as I go up, the slope is increasing, right? The slope is positive. So if the slope is positive, that means that on my derivative graph, my piece of the graph has to be above the x-axis. So I'm just going to make a little coordinate plane here. So anything that's here, anywhere like above the x-axis, that means that our slope is positive. Anything that we put down here, that means that our slope is negative. So in the first piece, we have a slope that's positive. So I'm going to draw something like that. So it's above the x-axis, so it's positive. Once I get to the highest point here, the slope becomes negative until my next slope of 0. So that means from this x-intercept to this one, it has to be below the x-axis. So I'm just going to, draw that. And then when I get to that slope of 0, the rest of the slope is going to be positive. So that means that from this x-intercept, the slope has to be above the x-axis. Oof, it's not my greatest drawing. But we don't necessarily right now need a very precise graph. So some people might have drawn, I'm going to probably regret doing this, but maybe some people did this blue graph. Woo! Something like that. Okay. It still follows the same criteria. It's above the x-axis, so it's positive up until this point. It has the slope of 0 here. Then the slope is negative, so it's below the x-axis, and then the slope is positive. So where we end this graph, or like where we turn back to go towards the other x-intercept, it doesn't matter at this point. Right now, we're just trying to get the general shape. So if someone drew the green one and someone drew the blue one, they're both correct because they are both fit the same criteria. Okay, so let's look at another one. So here we have, again, a regular function, f of x, and we want to graph the derivative. So again, first thing I would do is find where my slope is 0. So my slope is 0 around this point. So I'm just going to bring it right down, and that's going to be where it crosses the x-axis on my derivative. Again, here's another slope of 0, so I'm going to carry it down, so it's going to cross here. And then I have another slope of 0 somewhere here, so I'm going to put it up here. So I can see that I have a negative slope on the first piece, so I have to, in this case, be below the x-axis. My slope is then positive until my next slope of 0, so I'm going to do that because it's above the x-axis. Then my slope is decreasing to the next slope of 0, so I'm going to be below the x-axis. And then my last piece is positive slope, so it's going to be above the x-axis. So something like this. So this red graph is then the derivative of the blue graph. Okay, so you could draw it completely separate and not on the same graph, but I'm just trying to illustrate how they're related to each other and how we can use one to help get the other.